Hey everyone, it's Dr. Fox, and let's talk about the pleurae. In this video, we'll discuss the pleurae with an emphasis on the regions and structures covered or lined by each type. We'll discuss the clinical ramifications of various substances entering into the pleural cavity as well. So let's start with the serous membranes, which are the pleurae. Pleurae is the plural of pleura. If you recall, a serous membrane lines a cavity, and there are two distinct types or parts to any serous membrane. There is the visceral part, which covers the viscera, and then there is the parietal part, which lines the cavity wall. The pulmonary cavities are the lateral aspects of the thoracic cavity, which contain the pleurae and within the lungs. And so the pleurae have visceral pleura, which cover lungs, and parietal pleura, which cover the pulmonary cavities. The parietal pleura has four distinct regions. So looking here at this illustration, we can see this is a special case with a collapsed lung or a demonstration of atelectasis. And this is meant to be kind of a cartoonish lung. But everything that I have just surrounded is visceral pleura. Anything which is lining the cavity space, so on that side, would be parietal pleura. But let's look at the individual constituents of the parietal pleura. So when we talk about the cupula, that portion of the lung or the pulmonary cavity that extends up towards the root of the neck, we refer to that lining as the cervical pleura. Some people treat this as its own unique layer or region of the pleura. Some say that it's an overlap between adjacent layers, and those adjacent layers would be the costal pleura, which line the rib cage. Some people call this the costovertebral pleura, but that's a mouthful, so let's just call it the costal pleura. And then against the mediastinal surface, there's the mediastinal pleura. So the cervical pleura can also just be seen as where there's a coming together of costal and mediastinal pleura. But let's be complete and inclusive and call it by a unique name. There's also the diaphragmatic pleura, which would sit on the diaphragmatic surface of that pleural cavity, of the pulmonary cavity, excuse me. The pleural cavity is the space between, which is all of that. And this is a rather exaggerated illustration. In life, visceral pleura and the parietal pleura are right up against one another, such that as the thoracic wall or chest wall expands, so do the lungs. But within that pleural cavity, the average adult has between 5 to 15 milliliters of pleural fluid. And that just keeps any adhesions from forming, so it lubricates the pleurae from sticking to one another. Now, the clinical relevance of this is that we've created a space into which the lungs may expand as it expands, or contracts as the spaces contract. Sometimes different substances may enter into this cavity. So for instance, if air moves into this cavity, we call it a pneumothorax. So air in the pleural cavity is a pneumothorax. And one of the problems with this is as air moves in, we have this disruption between the relationship of the visceral and parietal pleura. We have a disruption between the surfaces of the lungs and the chest wall, and that is going to exert pressure on the lungs. So that's going to make inhalation more difficult. So a pneumothorax can very quickly progress to a collapsed lobe or collapsed lung state. That's a condition known as atelectasis. And with that, the lung can't be ventilated, which is problematic. Now, this can also happen obstructively if something enters into the conductive pathways of a lobe or of the entire lung itself. But this is the means by which this happens when air moves into the pleural cavity. We can also have an excess of fluid in that pleural cavity as well. We call that a pleural effusion. The more common is when there's something called a hydrothorax. Hydrothorax is when there is a buildup or an excess of pleural serous fluid in that space. So we might move from 5 to 15 milliliters to 200 or even 300 milliliters of fluid. Just like with cardiac tamponade, if there is pressure against the lungs can't expand during inhalation, and ventilation becomes difficult and then impossible. We can also have hemothorax, hemo meaning blood. If there's an interruption of any of the vessels and there's a bleed into it, then that can exert pressure on the lungs. Chylothorax, if there's an influx of lymphatic fluid. Or pyothorax or empyema is when there is exudate, colloquially referred to as pus, that enters into the pleural space. Just like pericardiocentesis can relieve an excess fluid from the pericardium, we can have thoracentesis, where we can enter into that pleural space with a needle to drain any fluid to help restore the ability of the lung to expand during inhalation, so as to relieve the pressure on the lung. All right, so let's assess the knowledge. Which part or component of the pleurae invaginate within the fissures of the lung? Is it the A, cervical pleura? Nope. B, costal pleura? Nope. Diaphragmatic pleura? Nope. Mediastinal pleura? Nope. So those are all the parietal pleurae. The correct answer is E, visceral pleura. The visceral pleura adheres to the surfaces of the lungs. Therefore, that's what invaginates within the fissures. Thank you so much for your time, and I look forward to talking to you in the next playlist. Take care.